Okay, so let's look at the first problem here. We're multiplying b cubed times b squared times b squared. Now, are any of these being raised to another exponent? I got b squared here, but is it being raised again to another exponent? No. Are all these the same base? When you multiply like bases, what do you do with their exponents? So this would be b to the what power? 7th power. That's your answer right there. Okay? You just do 3 plus 2 plus 2 equals 7. And the reason you add the exponents is because you're multiplying like bases, right? Let's look at the second one. Okay? Now, this whole thing is being squared, isn't it? And this whole thing is being cubed, isn't it? So let's write out what we've got. We've got b to the 5th. And then right here, this says negative b being what? Squared. So that means negative b times negative b, right? And then right here I've got negative b cubed, which is negative b times negative b times negative b, right? So I just expanded what we're actually doing. Now, first let's multiply the coefficients. The coefficient of all these, of this one is 1, and then here is negative 1, negative 1, negative 1, negative 1, and negative 1, right? There's no number in front of each of those letters, but it's understood to be negative 1. So 1 times negative 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 1 is what?
Negative 1.
Negative 1, good. And then this is b to the 5th, b to the 1st, b to the 1st, b to the 1st, b to the 1st, and b to the 1st. So since all of those are like bases, I got to add all their what? Okay, so 5 plus 1 plus 1 plus 1 plus 1 plus 1 is? So I got b to the 10th power. And so that's your answer right there. Let's look at the next one. Now, you see on this problem, this whole inside was being squared, wasn't it? But on here, this whole inside's not being raised to an exponent, and this whole inside's not being raised to an exponent, so we can just go ahead and multiply these, can't we? Let's multiply the coefficients first. Negative 7 times 4 times 6 is what? Negative what?
168.
Negative 168. Now, I'm going to multiply all the m's, and then I'll multiply all the n's. M cubed times m to the 5th is m to the 5 plus 3. 8?
8.
Good. When you multiply like bases, you do what with their exponents? Add. N to the 4th times n is? N to the what? 5th power. Good. So that's your answer on that one. So on this first one, look at the problem and tell me, is this whole thing being raised to another exponent here? If it were, I'd need to raise it to that exponent before I could multiply it by anything else, wouldn't I?
Yep.
But since it's not, I'm going to go ahead and multiply them. So first thing we multiply are the coefficients, right? Negative 5 times 6 times 4 is what? Negative 120. And then I'm going to multiply the a's. So a to the 4th times a to the 2nd is?
A to the 6.
A to the 6th, very good. And then b squared times b is b to the 3rd, very good. So that's the right answer on that first one. Let's look at the second one. Is this whole thing inside this parentheses being raised to an exponent? Is this one? No. So let's multiply the coefficients. What do you get when you multiply those three coefficients? Yeah, I think it's positive. Positive 48, is that what you said? And then we've got m to the 4th times m cubed times m. What is that?
8.
M to the 8th power. You just add up all their exponents. 4 plus 3 plus 1 is 8. And then let's look at the n's. The only n in the problem is n squared. There's nothing to multiply it by, so I just bring it on down, n squared, right? Look at this last one. What's the base of this? 2. What's the base of this? Do we have like bases?
Yes.
If we do, you add the exponents, so this would be 2 to the 7th power. It does not matter what the base is. If the bases are alike, you add the exponents. Imagine with me that we had stickman to the 3rd being multiplied by stickman to the 4th. Do we have like bases?
Yes.
So you add the exponents. This would be stickman to the 7th. It doesn't matter what your base is. If you're multiplying like bases, you add the exponents.